Hello everyone. Today I'm going to be solving this integral e to the 2 theta multiplied by cosine theta d theta. This is a integration by parts problem, and we're going to use Lyautey to determine what our u will be. So our u is going to be, in this case, trig comes first, so cosine of theta. So we're going to let u equal to cosine theta. Then when we differentiate this, du will be equal to negative sine theta d theta. Or dv is what's left over, e to the 2 theta d theta. So when we take the integral of this, our v would be e to the 2 theta divided by 2. So using our integration by parts formula, we know that uv, or this integral, will be equal to uv. Sorry, getting ahead of myself. Cosine theta e to the 2 theta. The whole thing will be divided by 2. Subtracted by the integral of v du. So we have e to the 2 theta, whole thing over 2, du, negative sign. So after this, we can rip the 1/2 out here, and then we have a negative being multiplied by another negative, becomes positive. So this will be equal to cosine theta e to the 2 theta over 2 plus 1/2 integral e to the 2 theta sine theta d theta. We're going to do another iteration of integration by parts using Lyautey. We can see that trig has more power over the exponential there. So our u be equal to sine theta. Differentiating both sides. Derivative of sine is positive cosine. Our dv is what's left over. We have e to the 2 theta d theta. V will be equal to e to the 2 theta over 2. So we're going to bring this down real quick. Cosine theta multiplied by e to the 2 theta over 2. Plus 1/2. We have 1/2 outside of this, so we're going to put big brackets and put in our integration by parts formula here, which is uv sine theta multiplied by e to the 2 theta over 2 minus integral v du. E to the 2 theta over 2 du is cosine theta d theta. Okay, we have that 1/2 on the outside there. I distribute it out. Cosine theta e to the 2 theta over 2 plus sine theta e to the 2 theta over 4. We can also pull this 1/2 out here, so this 1/2 would come out. This would make this negative 1/2, but then we have a positive 1/2 being multiplied on the outside, so it would be negative 1/4 multiplied the integral of e to the 2 theta cosine theta d theta. So this integral rotates around, and this trick is not so easy to see, but we know that this whole thing in its entirety will be equal to the integral that we had in the beginning. So we're going to have e to the 2 theta cosine theta d theta, which is equal to cosine theta e to the 2 theta over 2 plus sine theta e to the 2 theta over 4. Then we have this minus 1/4 here, e to the 2 theta cosine theta d theta, which is the same thing that we have on this other side here. So we're going to add this 1/4. Add this 1/4 to both sides. Get an LCD here. 1/4 plus 1 over 1 would be 5/4. So we have 5/4 integral e to the 2 theta cosine theta d theta be equal to all the stuff that we had written down before. Okay, so now we're going to multiply by the reciprocal. I need to get a little bit more space here. This whole integral be equal to e to the 2 theta cosine theta d theta, which is equal to 4/5. This multiplied here, this becomes 1, this becomes 2 for this, just for this one. So 2 cosine theta e to the 2 theta over 5. Multiply this here, this becomes 1, this becomes 1. We'll just be left with sine theta e to the 2 theta over 5. And integral does not have bounds, so you need to make sure you do not forget your plus c. You do not want to get points marked off after you go through this whole entire problem, doing all this nice work, and get points taken off because you forgot your plus c. So make sure you don't forget that, but that will be the answer to this problem. Thank you.